Good morning, guys. Today we're going to start chapter 10. So even though we haven't tested over chapter 8 yet, we're going to go ahead and start the next chapter. Haven't figured out exactly what I'm going to do about a chapter 8 test, but as soon as I figure that out, I will let you know. For now, we're just moving on. I always skip chapter 9, so that's why chapter 9 was part of your last project assignment, because I wanted you to see some of the stuff that's in there. That's just one of the chapters that we just don't have time to get to. So today we're starting a chapter on area. Area is one of those topics that can be really, really easy. They can teach it to 4th or 5th graders, and it can be really, really difficult. They could do area problems that you would have to use calculus to solve. So we're doing what would be considered 10th grade level area problems, which aren't super easy and they don't involve calculus, so they're somewhere in the middle. We are going to do some that involve either special right triangles or trig to find missing values, so that's what puts it at a 10th grade level. All right, so I'm going to put key here. You guys put your name. This will be for 6th period and for 7th period. It's possible I'm going to use this video for other classes later, so if you're in one of my other classes, no big deal. I may use this same video for you guys. Okay, so the base, the reason I'm mentioning base is because we're going to be doing area formulas, and area formulas call for different values to be plugged in from problems, and some of those values are base and height and and radius and some new words that you haven't learned yet, and some require diameter. So there's terms on here that you're going to be using in area problems, and so you need to know what a base is. So probably the most complicated part is any side can be a base. So any side of a triangle or of a parallelogram any side can be a base. So that may make you wonder, well, which one do I use? Well, you have to use the one that has a corresponding height, which we'll talk about in just a minute. So any side of a triangle or a parallelogram can be a base. So I'm going to use the one with a corresponding height. With a corresponding height. And then for a trapezoid actually has 2 bases. So we'll talk about that one when we get to lesson 10 too. So for this shape, any of these sides can be a base. I'm going to put this one as the base. But the only way I could use that as the base is if I had this corresponding height. So that would be a base because I drew in this corresponding height. If I use this as the base, then I would need this corresponding height. And if I use this as the base, I would need this corresponding height. So it depends on where you were given a height in the problem. We're used to base being on the bottom, but it doesn't have to be. So if this is our base, that's not the height. That side's leaning. The corresponding height would be this measure right here. That would be the corresponding height. And that brings us in, on the tip chart, to corresponding height. Sometimes they'll say corresponding altitude. These words are used pretty interchangeably. They do have a slightly different meaning. Altitude is the actual segment here. That's the altitude. The length of it is the height. So they have slightly different meanings, but they use them pretty interchangeably. Okay, so corresponding height is the height or altitude that is perpendicular to a given base. See, you can't really identify a corresponding height without knowing what base you're going to use. So these guys are given together. Base and height are identified together. So this, if I'm going to use this as the base, then this would have to be my corresponding height. They have to be perpendicular. We had a, a problem like this one on your last basic skills test, and a lot of people wanted to use this as the base, but we weren't given the corresponding height. So if the problem looks something like this, we were given this measure, and this is the corresponding height. They have to be perpendicular. So from that base, that's how tall that parallelogram is. So base and height go together. They have to correspond, and to know that they're corresponding is to be told that they're perpendicular to each other. That's how we know they're corresponding, because they're perpendicular to each other. Okay, those are the only two that we need today on your tip chart. And I should have mentioned that this is in Google Classroom. So you can print this, and you can print the notes paper that goes with this lesson. So those are the first two on the tip chart. And now we're ready to get to the problems. Today, I probably should just leave out a date. I think I'll leave off a date. So you can put today's date in there, and just in case I use this video for other classes. All right, so we're doing two shapes today. They are triangle and parallelogram. So you need these two area formulas. I write these on the top. Area formula for all the parallelograms, it's base times height, and the area formula for triangles is 1/2 base times height. Okay, let me show you why that is. Okay, so in a rectangle, which you've done area problems with rectangles for a long time now. You may have called it length times width, or you may have called it base times height. But since a rectangle is a parallelogram, area formula is base times height. You can call that length times width. Area, it actually means how many squares are in the shape. And so you can see, since I divided up like a grid, that there are 12 spaces, and that is a result of going 3 rows of 4 boxes. 3 rows of 4. When you multiply those, that would be base times height, and that gives you 12 squares. So that's the actual concept of area, is how many squares fit inside a shape. In this case, 12. And that's why we give our answers as squares, like square centimeters, square feet, because you're telling how many squares are actually in there. When you're looking at a parallelogram, if you were to take scissors and cut right here, cut that off, and pick that right there up and move it to this side, like that, you would have that same shape, the same one we just did. And this is your base, and we cut that part out and moved it over here. So this is still the base, and that is how tall remember, this is the original parallelogram, this right here. And that right there is the height of it. So that's the height. So it's still base times height. So that formula works for parallelograms. It's this base times this height. And triangles, I don't know if you've ever thought about this before, but triangles are always half of some parallelogram. So if I draw that line right there, I've got myself a triangle. So that's why the formula is half base times height, because the triangle is always half of some parallelogram. If you draw any triangle like that, it's half of a parallelogram. Even if you draw a really skinny, ugly triangle like that, suppose this is our triangle, that triangle is half of a parallelogram. So that triangle right there is half of the base times the height, which would be the area of that entire parallelogram. So that's where the formulas came from. Okay, now let's do some. Some of them are going to be lower level than 10th grade, like this problem right here. So the first thing you should always do with all area problems in this whole chapter is write down the formula first. So triangles, excuse me, are 1/2 base times height. So 1/2 times 10 times 7. You can multiply these and then half it, or you can multiply that first number and then multiply it by 7. That doesn't matter. So I like to get smaller numbers as fast as I can. So half of 10 is 5, and 5 times 7 is 35. 35 inches squared. So some problems are going to be pretty straightforward and pretty basic like that. When they have the base on the bottom and the height right there for you, those are pretty easy questions. They get harder. They get 10th grade level. So let's do the next one. It says find the area. So I always start by writing the formula. 1/2 base times height. In a right triangle, in right triangles, the legs can always be used as the base and height because there's a right angle. So if you use 4 as the base, 3 as the height, or if you use 3 as the base, 4 is the height. And since we're multiplying, it doesn't matter what order we multiply in. So you can use those interchangeably. I'm going to call the base 4 and the height 3. And then you do half of 4 is 2, and 2 times 3 is 6. So this is 6 centimeters squared. Always put the square on your unit when you're doing area problems. That's how many squares would fit inside that shape. Okay, this one says find the area. This time this is not a triangle. This is a parallelogram. If you ever see dashed lines inside shapes, that's there to just give you a measure. So it's not like it's a triangle and a trapezoid. It's one shape, one parallelogram. That's just giving you a measure. So the area formula is base times height. Always write down the formula first. Okay, so this was the problem on your last basic skills test that gave people trouble. You cannot use 7 as the base because we don't know how tall this shape is from that base. To use 7, we would have to know this measure. And we don't know that measure. So we cannot use 7 as the base. But if you turn it this way, we have this measure that we can use as a base, and this would be the height of it. Now, some people wonder, like, the right angle's over there, so how do I know that this is a right angle? Well, a couple reasons. It's a parallelogram, so these are parallel. Or you could do this. Since it's a parallelogram, the 5 can be moved over here. So that's 5 meters. And then you can look at it this way if you want to. So that's 5, and this is 6. That's the base and height because they're perpendicular. Base and height have to be perpendicular. The 7 really has nothing to do with this problem. So this formula plugged in would be 5 base, 6 height, 30 meters squared. So the big mistake on the basic skills test is some people did 7 times 5 and put 35. They were different numbers, but anyway, 5 can't be used as the height because from the 7, that 5 is leaning. And a height would have to go straight up like this and make a right angle. And that measure is shorter than 5. So you can't use 5 for the height. Okay, example 4. It says find the area of the equilateral triangle. Those are important words. All right, so notice this problem didn't give you very much. But whenever it says area, I start by writing the formula. See, the formula drives the problem. You know, when you're not given much, you you really have to think, okay, what do I need, and do I have what I need? And the formula is what tells you what you need. You need base and you need height. Well, I have a number for a base, and it's equilateral, so all these are 12. So area equals 1/2 times 12. So the formula is what tells me what I need. I need a height. So I'm going to draw in the height. This is what I need. I need this line right here. And at this point, I don't know that. So I need to think about these words, equilateral. Equilateral triangles are also equiangular, which means all of these angles are 60, because 180 divided by 3 is 60 degrees. So an equilateral triangle has all three angles the same, and that means they're all 60s. And this top angle is 60, but it's got an altitude drawn in there, which is going to cut that in half. Or if you didn't think about it that way, since you have a 90 here and a 60 here, in this triangle right here, this little half triangle right here, this would have to be a 30. So this is a 30, 60, 90 right triangle right here. Not the whole triangle, but this one right here. So this is what I was saying about some of these problems are going to be 10th grade level problems. You can't do this problem until you know how to find this missing height, and we're going to find this missing height using this special right triangle, 30, 60, 90. All right, so when that altitude was drawn in, when that height was drawn in, it came down here and it did something to this side right here. It cut this side in half. And normally an altitude, well, sometimes an altitude doesn't do that, but in any isosceles triangle, or in this case, equilateral, so any triangle where these two sides are the same, that altitude's going to come down here and it's also going to bisect this 12. So these are both 6. So I don't need that 12 anymore. All right, just looking at this special right triangle right here, this 30, 60, 90, across from the 30, this is A. Across from the 90, this is twice A. Across from the 60, this is A radical 3. That's from chapter 8, where we learned about special right triangles. And so if A is 6, then this side right here, A radical 3, is 6 radical 3. So that's our height, 6 radical 3. And then you just multiply these. 1/2 times 12 is 6, and 6 times 6 is 36. This answer is 36 radical 3 units squared, because they didn't tell us what it was measured in. That's your answer. Now, if they ask you for that answer as a decimal, or round, if they say round to the nearest tenth, then you can just type in 36 radical 3, and you can round that answer. It's about 62.4 units squared. But this is probably how they're going to want you to leave the answer. Just leave it as a radical. All right, example 5. The area of a triangle is 24 feet squared. They're giving us the area. As soon as I see these words, area of a triangle, I'm already writing this down. 1/2 base times height. And they gave me the area. So since I have a formula, I have a place to put that. The area is 24. It goes right here. So I'm going to change that A to 24. So 24 equals 1/2. I'm going to plug in the base. It says the base is 8. Times the height. It says find the height, so I don't know it. This is what it looks like when you get it all plugged in. So you write down the formula. You put 24 where area goes. You put 8 where base goes. It says find the height. You leave that as H. Then you solve this. So 24 equals 4H. Then you divide by 4. So H is 6. And that will be regular feet, not square feet, because it's not area. Area is 24. The height is 6 feet. So sometimes they give you problems where they ask you for a different part of the formula besides the area. Okay, the last 2 problems are, you have a few of these in your homework. Again, they're asking us to find something instead of area. They're asking us to find the height. So notice this problem just gives you a lot of stuff. What they didn't give you is area. So first thing I do is I look, okay, I find out what shape it is. So the bold lines, that's what shape it is. That's a parallelogram, and that is base times height. And I'm looking for h. It says find h. I'm looking for this. So I need to plug in area, and I need to plug in base. So if I'm looking for this height, then this is the corresponding base. It's actually turned like that. So that's the base, that's the height. So that's going to be 16 times h. Remember, I'm looking for h, so I can't plug that in. It's unknown. So what I need is area. Well, they didn't give me area directly, but I can find it because this problem has another base and height combination. So this base here, 10, goes with this height. That's how tall that parallelogram is from that base. So since the formula for area is base times height, I know the area is 10 times 8, which is 80. So that's what I'm going to plug in right here. So 80 equals 16h. That looks weird because it's a little smaller. And then to get h by itself, you're going to divide by 16. H is 5. Okay, there is a little bit of a shortcut. It's not much of a shortcut, but there's a little bit of a shortcut to these kind of problems. If you see that they're giving you a base and a height and another base and a height, you can do the problem like this. Base 1 times height 1 has to equal base 2 times height 2 because it's the same area. So that area has to be the same no matter what base and height they give you. So if you plug it into this, the base that corresponds to the height they want, 16 times h, so we're calling this base 1 and this height 1, must be the same as multiplying base 2 times height 2. And you get this, 16h equals 80. And that's what we solved. Divide by 16 and you get 5. So this is kind of, it's not much of a shortcut, but it's a little bit of a shortcut. For a given problem, if you have two different base height combinations, then their product must be the same. That even works on triangles, even though it's a different formula. So let me do it the other way first, and then I'll show you the shortcut way. So the formula for a triangle, as soon as I see that thing's a triangle, those bold lines, 1/2 base times height, they're looking for x, which is a height, and that height corresponds to this base. So they're looking for x, and x corresponds to that base right there. So the base and height are 10 and x. So area equals 1/2 times 10 times x. And that is 5x, but I don't know what the area is. So to find the area, I'm going to use the other base height combination, which are 12 and 8. So area equals 1/2 base times height. 1/2 of 12 is 6, 6 times 8 is 48. So you can plug in a 48 right here. 48 equals 5x. Divide by 5. And this gives you 48 divided by 5, 9.6. So that's how tall that is from that base of 10. That's x. If you want to do it the shortcut way, even though it's a triangle and the formula would be 1/2 base times height, just each pair of base height products have to be the same. So 10 times x must equal 12 times 8. You get 10x equals 96. Divide by 10. You get 9.6. So it's a little bit of a shortcut. Not much of one, but a little bit. All right, so that's our first lesson on area. That is parallelograms, including rectangles, and this is triangles. So these are your 2 area formulas for the day, and your homework is from lesson 10-1, and just be sure to save all of your homework in your binder for now. So you don't have to take a picture of that and send it to me. Some of you have been doing that, and that's fine. I love to see your pictures pop up, but you don't have to do that. You can just save it in your binder for now, and I'll tell you what the plan for that is going to be moving forward as soon as I figure all this out. The rest of this video is I'm gonna take some time to just go over some problems that you were assigned recently. So you can, if you're confident with the problems that you've done so far, let's see, I think it was a review assignment that I gave you, then you can just stop right here. But if you want to stay, to keep watching, I'm gonna just go over a few problems from it was page 534. So I'm gonna do a few of those. And then I may even go over some problems from that quiz that we took in class. So yeah, I'm gonna go over some problems. Again, if you are all good, you got them all right on that review, you do not have to keep watching. You will not hurt my feelings, and in fact, I won't even know y'all. Okay, so number 13. You can also pause this and come back to it later if you've just had enough for now. All right, so number 13, this is all from page 534 that you were assigned recently. It says there's a square garden, and the square garden is 50 feet on each side. And it says that you're gonna run a hose from corner to corner in this garden. And they wanna know how long that hose is. And they wanna know to the nearest tenth. So you could do the Pythagorean theorem, a squared plus b squared equals c squared, because there's no angles given. So you could do that, and that would give you the answer. Or since these are the same, that means this thing has to be a 45, 45, 90 triangle. So we learned in chapter 8 that these are A, and this is A radical 2 whenever you have a 45, 45, 90. So it's 50, 50, and this would have to be 50 radical 2. That's the quickest way to get this answer, 50 radical 2. Now, that is not rounded to the nearest tenth like they asked. So you type in 50 radical 2, and that gives you 70.7 feet. So that's approximately how long that hose is. About 70.7 feet. If they ask for nearest whole foot, I can't remember the problem because I'm not looking right at it, but it would be 71 feet. Okay, again, when I'm going over problems like this, if I'm doing a problem that you did not miss, you can just fast forward on through that part. All right, the next problem I picked out was number 18. It said Linda's flying a kite, and she lets out 45 feet of string. So 45 feet of string, and there's a kite. And she anchors it to the ground. So she's tied that thing off to the ground. There's an angle of elevation of 58 degrees. So from the horizontal, that's what an angle of elevation is, up to the kite, that is 58 degrees, and they want to know how high this kite is. One part that some people forget when they do drawings, they forget to label the X side, and then when they don't label the X side, it looks like you don't have enough labeled on the problem to figure out whether it's sine, cosine, or tangent. So always label your X, and then it'll look like the problems that we did in class. So here's our angle of reference. I know that this is a trig question because it's a 58 degree angle. So that's not a 30, 60, 90, it's not a 45, 45, 90, it's 58. So I'm gonna do a little trig. Across from that angle, this is called the opposite side. Across from the right angle, this is called the hypotenuse. The adjacent side is blank. That means this is a sine problem, opposite and hypotenuse. So you write sine. The angle always comes next. equals opposite over hypotenuse. And whenever the x is on the top, whenever you write a trig equation and the x is on the top, that is when you multiply. So you grab your calculator and you type the normal number first, 45, times sine 58. And you get 38.2 degrees. X is approximately 38.2. I said degrees, but I meant feet. 38.2 feet. That's how to do number 18. Then number 19, I picked that one. It is a vector problem. And the vector looked like this, and they want the magnitude and direction. They want magnitude and they want direction. And here's what they gave us. They gave us that this measure is 50. It was measured in kilometers. And this measure is 200. It's measured in kilometers. And those are the numbers that we're going to use to find magnitude and direction. So to find magnitude, they're really asking us how long this is. Magnitude is the size of the vector. In this case, it would be in kilometers. So you'll do a squared plus b squared equals c squared. 50 squared plus 200 squared equals c squared. This is 2,500 plus 4, 0, 0, 0, 0. And then you add those together. Plus. And then square root. So this is 42500. And then square root. And when you punch that into your calculator, you get about 206. 206.2 kilometers. So here's what all I was doing. So 50 squared plus, what was it? 200 squared. You get this. And then I want to square root that. So I did square root, and then I pulled up the answer, and it gave you this. That is magnitude. Now, to find direction, we need this angle right here. We need that angle. We call that theta. And to find an angle, you're going to have to use some trig. And this would be the opposite side. This would be the adjacent side. The hypotenuse is blank. Now, we found the hypotenuse, but I wouldn't use that number, because if I made a mistake and then I use it to find the angle is going to be wrong. So I use the given numbers. So this would be tangent theta equals opposite over adjacent. And then since the angle is missing, that's when you use the second button on your calculator. Use the second function button to undo tangent, to get rid of this word tangent. So you do second tangent, and then you type in 200 divided by 50, and that gives you about 76 degrees. So theta is about 76 degrees. Now, there's more to direction than just that angle measure. You have to tell you have to use these compass terms. So this is north, this is south. When you're looking north, it spells we. Or some of you do never eat soggy waffles. That's fine too. So the angle is coming from west, and then it's heading down. It's heading towards south. We talked about this where the arrow will point to the word that you put first. So this is south of west. 76 degrees south of west. Magnitude, direction. All right, and then there's one more that I picked out. Number 22. It's the whale watching problem. It says that there's a whale watching boat, and it leaves port and travels 12 miles due north. So 12 miles due north. And then it heads 5 miles due east. So 5 miles, I think it said east, it may have said west, so. I'll do it like it says east. Okay, what direction will they head back to port? So here's the boat right here. And they want to head back to port. So they want to go this way. They want to travel on this vector. So this is the angle that they're going to travel. And that's the angle that they want. So this would be the opposite side, this would be the adjacent side. So you would go tangent of theta equals opposite over adjacent. And so just like the last problem, we're gonna type in second tangent, that's what you do when the angle's missing, and type in 12 divided by 5. And you get this angle, 67.4 degrees. If it said nearest whole degrees, it would be 67 degrees. So theta is approximately 67 degrees. Or 67.4, that'd be fine. Okay, we're gonna head this direction. So this is kind of weird. We would be heading west, but then we're gonna turn down from heading west. So the direction is turning, basically it's turning down from going west. So it's south of west, south of west. That part, this direction was a little confusing for this problem because if you think about the situation, they're heading that direction and they're gonna actually need to turn their boat on this, like this large angle like this to actually turn that way. So that kind of confused people, I think, a little bit about that, those compass terms for the direction. But if you, I'm trying to think of how to word this because it's just a little confusing. But once I get that angle labeled in there, I really don't have to worry about where it was going. I'm just looking for this angle right here. So I'm kind of thinking the boat, if I traveled back the path I came, I would go this way and then turn down. But instead I can go directly there. So I can turn down at that same time. That's where the south comes in. All right, so I know that's a little confusing. On a test question, I probably wouldn't ask you one where they have to take their boat and turn it around, and that just makes the compass directions a little confusing for people. All right, so those are problems from page 534. Normally I would ask y'all what y'all wanted to see, but since we're doing it this way, I just picked out a few that I thought might give you trouble. I think I'll stop there for today. Tomorrow I'm gonna do a lesson on 10.2 and I'll go over some problems from lesson 10.1. The only thing I haven't talked about with y'all is the quiz, that last quiz that we took. So hopefully enough of you took a picture of the answers that those have made their way around. If I get some time, I'll pull up that quiz and I'll do some for y'all. All right, so thank you guys for being flexible in the way that we're learning, and I just appreciate y'all so much. And I hope that y'all are having good days at home, and look forward to seeing you soon. Y'all have a great day.